The region R is bounded by the graphs of f of x equal 2x minus x squared and g of x equal x on the interval from 0 to 1. Try both the washer method and the shell method to find the volume of the solid formed when R is revolved around the x-axis, determining which is easier. Okay, let's go ahead and first of all draw our region. I'm going to kind of spread this out so we can see it here. And f of x is 2x minus x squared, which is a parabola that opens down. And if we put in 0, we see that the y-intercept is 0, and we could find the x-intercept by factoring an x out and putting this equal to 0, and there's one x-intercept at 0 and the other one is at 2. The vertex then would be at 1, and if we put a 1 in here, we can see that it is at 1, 1. So our parabola would look something like this. And then our other function is g of x equal x, so this is just the line y equals x. And so our region would be right in here. Let's first use the washer method. So if we're rotating this around the x-axis, then our little slices would go this way, have a little thickness dx, and you can see that we would have these washers here. It has this hole in the middle. So let's go ahead and set up our integral. We would be integrating from 0 to 1, our x values from 0 to 1. And we have pi. I'm going to go ahead and write it out in front because it's going to be in both pieces. And so pi, this big radius squared, which is the upper function squared. So that's going to be 2x minus x squared squared minus the lower function, which was x squared. The lower function is x, and then we square it because it's pi r squared. And then our little thickness dx. So let's see if we can express this in a little easier form to integrate. So we have pi 0 to 1. If we multiply this out, looks like we're going to have 4x squared. We're going to have negative 2x to the third twice, so negative 4x to the third, and then plus x to the fourth, and then we still have this minus x squared on the end dx. So we can go ahead and do the integration now. Let's start with this x to the fourth here. So that would be 1/5 x to the fifth, and then on this x to the third term, that would be minus x to the fourth. And then these two combined would be 3x squared, so when we integrate that, that's going to be plus x cubed, and we're going to evaluate that between 0 and 1. So putting in 1, these two are going to cancel, and so we would have 1/5 pi, because the lower limit's going to be, when we put in the lower limit, we're going to get 0. So it looks like the volume of the solid that's formed is going to be 1/5 pi. Now let's consider the shell method. So with the shell method, our shells are going to go this way, and so they're going to have a little thickness dy, and then we will be rotating this around, and so we need this circumference with this radius. So as we set this up, we are going to write things in terms of y because our little thickness was dy. So y goes between 0 and 1. And we've got 2 pi, and we see our radius here is going to be y. And then we need to express the height of these shells, and so that's going to be this right function minus the left function, but we need them expressed in terms of y. So this function is just simply y equals x, so we've got y minus this function here. Right now we have y as a function of x, and we want x as a function of y. And it is doable, but it's going to involve some algebra. So right here I'm kind of tempted to say the washer method's easier, but let's go ahead and do this and see what kind of an integral we get. So let's, in order to solve this for x, we're going to need to complete the square, and I'm going to move this to this side and this one over here. So it's going to be x squared minus 2x, and a place to complete the square, and then minus y, and then a place to complete the square here. So if we complete the square on this, this is going to be a 1 because middle divided by 2 and squared, and we got to do a 1 here. This will factor into x minus 1 squared, and then this side is minus y plus 1. if we're solving this for x, so we're going to get rid of the squared by square rooting. Normally we do a plus minus, but we're in quadrant 1, so it's going to be a positive. And then x will be alone if we add 1 to the other side. So we've got square root of minus y plus 1, and then a plus 1 on the end. So that is the function that goes right here. Square root of minus y plus 1 with a plus 1 on the end. And so here we have our circumference, here we have our height. We need to multiply it by our thickness. Well, that does not look like something fun to integrate. Of course, we could move the 2 pi out in front and the y squared wouldn't be hard, but we would have something that's not fun to do right here. And so we have determined that for this particular problem, the washer method is the way to go.